In the criminal justice system, the people are represented by two separate yet equally important groups: the police who investigate crime and the district attorneys who prosecute the offenders. These are their stories.
Hello?
Hey, we have a case for you. 18-year-old Ethan Goldberg was murdered by his pool at his house.
Okay.
I need you there as soon as possible.
Okay, sure, I'll be right there. Dang it, I was on vacation. So, what is the situation?
So basically, this guy just like died by his pool, but I'm not sure. I just got here
Let's
too.
take a look at the body. Oh, this does not look good.
This looks like he was working on something.
What was that?
I don't know. It looks like
Treasure.
calculus.
Calculus?
Was he looking for something?
It says treasure right here.
Huh.
Judging by the remnants of this cup, it looks like our victim was poisoned. Judging by the excessive amount of blood coming out of his mouth, it was very strong. Look to evidence and further examine our equation. So, what do we have here?
So our forensics team analyzed the pavement for rubber and figured out that our murderer took this path when they left.
So it looks like this is the origin of the murderer's escape. So this is where the trail ends. So I guess this is where we determine where the murderer went.
Now that you mention it, this looks like a polar graph with this origin. So that means that if we figure out the slope at that point, we can figure out where the murderer went. So I've determined from the lines on the street that the curve is about 1/4 theta. Now when we look at it, this does look like the curve that we found on the street. So what we need to do is we need to find the slope of 0.25 theta at theta equals 21 pi over 4, because our forensics team determined that the theta at which the car left was 21 pi over 4. So we know that dy dx equals dy d theta over dx d theta. So since y equals r sine theta and x equals r cosine theta, we know that y equals 0.25 theta sine theta and x equals 0.25 theta cosine theta. From this we can find that dy d theta equals 0.25 sine theta plus 0.25 theta cosine theta. We do this by using the product rule. So it's 0.25 theta and sine theta. Now that's the derivative of this is 0.25 and the derivative of this is cosine theta.
Now dx d theta equals 0.25 cosine theta minus 0.25 theta sine theta. Same thing, product rule. We can do 0.25 theta and cosine theta. The derivatives are 0.25 and sine theta negative.
So now we know when we divide this that dy dx equals So once we plug in the numbers, we can get dy dx equals
0.25 sine 21 pi over 4 plus 0.25 21 pi over 4 cosine 21 pi over 4 over 0.25 cosine 21 pi over 4 plus 0.25 21 or minus 0.25 21 pi over 4 cosine 21 pi over 4.
So when you put that in our calculator, we get that it equals negative 1.129. And this is the slope, and therefore the direction in which our murderer went.
So this book was really important to the victim. He was working on a problem. We should finish solving it.
I got this. At the time of death, our victim was working on the problem, what is the area between r equals 1 minus sine theta and r equals 5 minus cosine 2 theta? So we need to figure out first which equation is larger than the other. So in my calculator, I put in the two equations, 1 minus sine theta and 5 minus cosine 2 theta. So when we graph that, we see that the bigger equation is 5 minus cosine 2 theta. So we can use the equation a equals
1/2 the integral from alpha to beta of r1 squared minus r2 squared d theta.
So since the bigger one is 5 minus cosine 2 theta, we can do a equals
1/2 the integral from 5 minus cosine 2 theta squared minus 1 minus sine theta squared d theta.
Now on the calculator, I just had the bounds 0 to 2 pi, and it looks like it shows all of the graph, so I'm going to keep my bounds 0 to 2 pi. Now when we put that in our calculators, just like this, we can get that the area equals 75.398. So the answer is 75.39.
Wait a second, that sounds interesting. The direction in which the murderer was going is headed towards a storage facility. That could be one of the lockers.
You're right.
Let's go! Aha! There are the safes!
Okay.
These numbers look really familiar.
This looks like the answer to the problem our victim was solving.
Oh, wait, it's locked. There needs to be a combo.
There's a clue!
A clue?
Area of the curve, r equals sine squared theta. Maybe that's the combo.
Maybe it is.
Alright, so we need to find the area of the curve, r equals sine squared theta. Now, I put this in the calculator, and I have got the bounds 0 to 2 pi, so let's just check to see if that works out. And that looks like we pretty much see the entire graph from 0 to 2 pi, so that's going to be our integral bounds. Now, we can use the equation a equals
1/2 the integral from alpha to beta of r squared d theta.
Now, when we put in our equation, we get a equals
1/2 the integral from 0 to 2 pi of sine squared theta squared d theta.
Now, we can put this in our calculator, and we get 0.5.
The integral from 0 to 2 pi of our equation squared d theta.
And we get that the answer is 1.178.
So, is it 1.178?
Yeah.
Alright. 1.178. It opened! Bowling pins? Quick, we need to take these to the lab.
You're right.
So, this is all the evidence that we've gathered from the scene. We suspect traces of poison in the victim's drink.
Perfect. A lab analysis tells us there's poison. Just give me a minute. Oh, the results changed color. It must have been poison in the drink.
So, the lab said that the cup tested positive for poison.
That means that the victim's murder was no accident.
What would be the killer's motive? It must have something to do with the treasure.
The pins!
Oh, you're so right. What are so important about some bowling pins?
I don't know. Let's go to the lab and find out.
What's up, Doc? So we think there's something important about the bowling pins that we found at the storage facility.
Okay, I can test it if you want me to.
Yes.
Due to the carbon dating technology of this microscope, I have determined that this bowling pin was from 1912.
1912? That sounds familiar. It's the date that the Titanic sank. We have reason to believe from the lab that these bowling pins were actually from the shipwreck of the Titanic.
Wow, that means we should get them to an expert to find out for sure.
Yes, there's a historian right down the street.
Let's go.
Stop right there and give me those bowling pins. I put my blood, sweat, and tears into getting those bowling pins. I poisoned the man, I ran someone over So you're funny. You're not gonna get them. So hand them over, or I'll shoot you.
Hey, wait a minute. Put the gun down. We don't know if these bowling pins are real or fake yet. We need to go to a historian. You don't know if they're real, so all this effort could have been for nothing. You don't know that right now. You have to find
My leg! I'm dying!
You're under arrest for the murder and the death of the victim, Ethan
I've been
Goldberg.
betrayed! You told me you would give me the bowling pins!
I never said
I
that.
lied to
You have the right to remain silent. Everything you say
My blood,
will be
sweat,
held
tears.
against you.
My blood, sweat, and tears!
Wait, why aren't you lounging?
Oh my god.
Inspector, I found the perpetrator.
Anyway, I need to get some flashcards and we need to go. Anyways. I'm eating my hair.
But they won't see it. They'll just be like, wow, we should get them to a
It's like
literally dripping all over me. Stop right there.